Hello, this is the luckiest maths teacher in the world. Today we're looking at matrices. Now, matrices are just the plural of the word matrix, and we're not talking about the movie, we're talking about, in mathematics, a rectangular array of numbers enclosed in a box. So let's say 4, 5, 7, minus 2, 1, 9, or something like that. So that here is a matrix. Now, it's very important that we understand the size of a matrix. So the size of a matrix is just the number of rows and columns that it has. So rows go across like that. So this matrix has 3 rows. Columns go down. So this matrix has 1, 2 columns. So this matrix has 3 rows and 2 columns. So the way we write its order, we always write rows first. So this is a 3 by 2 matrix. So there are matrices of all different sizes. Now, matrices are just boxes of numbers and they encode information. So they represent information. What we're going to want to do with these matrices, we're going to want to add and subtract them, multiply them as well. So it's important we understand how to find the order of a matrix, because the order tells us whether we can in fact add or subtract or multiply matrices. So to give you another example, let's say I have one that's 3, 6, 9, 5 here. This is a 2 by 2 matrix. 2 rows going across and then 2 columns going down like that. Okay, so the order of a matrix is the number of rows times the number of columns. Now, to be a proper matrix, there has to be the same number of numbers, which we call elements, in each row. There also needs to be the same number of entries or elements in each column. So this is a proper matrix because there are 2 entries in each row and 2 entries in each column. But if I had a matrix like this, so right up here, let's say minus 7, 3, and then 1 here like that, that's not a proper matrix. The reason is this first row has 2 entries or elements, whereas the second row only has 1. So, has to be like full, if you like. So, we understand how to find the order of a matrix. Now we're just going to look at some special types of matrices. So please pause and copy this down if you need it. So the first type of matrix we'll go through is a square matrix. So I said matrices are a rectangular array of numbers. Well, a square is actually a type of rectangle. And that's where it has the same number of rows as columns. So these types of matrices will be n by n. They'll have the same number of rows as columns. So an example of a square matrix, 1, 1, 1, 1. That's a square matrix because it's 2 by 2. This matrix here, 3, 0, 5, this is not a square matrix because it has 3 rows and only 1 column. But this last type of matrix is another special type of matrix. It's called a column matrix. In more high-level maths, they'd refer to it as a vector or a column vector. So a column matrix has 1 column only. So the one I just went through, 305, is an example of a column matrix. A row matrix, very similarly, it has only 1 row. So if we have one like 3, 2, 4, this here is a row matrix. It has 1, 2, 3 columns, but only 1 row. Okay, so now I need to talk about a special type of square matrix. So please pause and copy this down if you need it. So let's say I have a matrix like this. Now we call the leading diagonal this diagonal here. So that is sort of the long diagonal. So if I have 1s along the leading diagonal and 0s elsewhere, we call this the identity matrix. Now, it's important to note that there are infinitely many. There's a different identity matrix for each size of a square matrix. So that's a 2 by 2 identity matrix. We usually call them I. So the identity matrix of 3 by 3, it would have 3 times 3, 9 elements. So it'd have 1s on the leading diagonal, and it'd have 0s everywhere else. And there's a 4 by 4 identity matrix. There's a 5 by 5 identity matrix. Always 1s along the leading diagonal and 0s elsewhere. So the identity matrices, you'll see them more when we do multiplication. They're important because if you multiply a matrix by the identity matrix, it doesn't change it. So the identity matrix is sort of like the number 1. Multiply by it and you don't change the number. All right, I hope you've learned something from this. This has been the luckiest maths teacher in the world. Have a great day.